All right, guys, so we've looked at altered states of consciousness in general, and now we're going into sleep specifically. So today we're looking at sleep and biological rhythms. What is sleep? It's the reversible behavioral state of perceptual disengagement from and an unresponsiveness to the environment. In other words, it is reversible, so you can go in and out of sleep. Perceptual disengagement means that you are not perceiving the five senses. So touch, smell, hearing, all of that, you're not getting. It's there. You should register it if you were in normal waking consciousness, but you're not really engaging in it. And an unresponsiveness. So not only are you not engaging in that, you're not responding. You're not moving around. You're not actively doing things. So what is a biological rhythm? It's the cyclical change in bodily functions or activities that repeat themselves through time. So rhythm generally is something that repeats itself. So things like our body temperature, blood pressure, blood sugar levels, digestive secretions, secretion of certain hormones, our mental alertness, and our sleep-wake cycle. These are all different biological rhythms that occur to us every single day. So here's just some example of some biological rhythms. You don't need to know those. Some occur annually, some occur monthly, such as the ovarian cycle. We're going to look at the circadian rhythm, which occurs around about every 24 hours. We call anything that occurs less than 24 hours an ultradian rhythm, and we're going to look at that as well, but they can be split into smaller ones. So biological rhythms are maintained and controlled by internal mechanisms or neural systems, and we often refer to these as our biological clock. All right, so the control of these are our biological clock, and you may have heard of that in reference to our ovarian cycle, but perhaps not in regards to sleep and other types of biological rhythms. And it's the brain that's coordinating all of these. So they function in a synchronized way. The brain makes sure that everything's going on right when it needs to. So two categories that we're looking at, as I mentioned, are circadian rhythms and the ultradian rhythms. So what is a circadian rhythm? We did just say this before. It's the biological clock that involves changes in bodily functions or activities that occur in a cycle of 24 hours. So you don't need to know this, but this is a good example. It includes your alertness as well as your actual sleep. So the sleep-wake cycle. This is internally produced and persists despite environmental cues. So in other words, whether or not you are in a room that has light and dark, you could be in a completely dark room, isolated from everything else, the sleep-wake cycle will still persist and occur. It is, however, influenced by environmental things, so stimuli such as the sunrise and sunset, and these help keep it in sync with the Earth's 24-hour rotation. So as I said, you can be completely deprived of environmental cues. The sleep-wake cycle will still exist, but what we've found when we've done studies of that is that it will slowly extend towards a 25-hour cycle. So you may even find just a little bit, now that you guys are doing remote learning, that you are waking a little bit later, sleeping a little bit later if you're not really managing going out and about and doing your normal activities. That's why we try and still schedule your classes. Environmental cues. So we call these environmental cues Zeitgebers. I don't know if I'm pronouncing that correctly. It's a German word. And these Zeitgebers, or environmental cues, such as sunrise and sunset, reset and match a biological clock to the environmental cues, or they can just influence our biological clock. And when that happens, it's called entrainment. So the environmental cues impacting our sleep-wake cycle and our biological clock is called entrainment. And here you can see an example. This is our sunset, our sunrise, a lot of alertness, and then we start to get this lack of alertness. So that influencing our biological clock is called entrainment. Now, the main environmental cue is light. And you may have heard this before because you may be told that you need to put your phone down at night time so you can get some sleep. So light is the main environmental cue that influences the sleep-wake cycle. In particular, we are looking at something called the suprachiasmatic nucleus. And this is a tiny little part of the brain's hypothalamus. It's just above our optic chiasm, which is where the optic nerves cross over to connect to the brain. So where it does that crossover to swap to the hemispheres is called the optic chiasm. And just above that, supra meaning just above, is our suprachiasmatic nucleus. And it's important that position because it is detecting light. So it's getting information from the eyes and it is then sending that information to the pineal gland. So the suprachiasmatic nucleus is our predominant structure that regulates the timing and activity of our sleep-wake cycle. And what it does is it gets information about the incoming light from the eyes, and that adjusts our sleep-wake cycle accordingly by sending messages to our pineal gland. Now, the pineal gland can adjust this sleep-wake cycle through the secretion of a hormone called melatonin that goes into our blood. And I noticed last lesson a few people going, is melatonin the same as melanin? And often they are confused. So melanin is the color that is given to your skin when you're exposed to sunlight. Melatonin is our hormone that regulates our sleep-wake cycle. So higher melatonin levels are associated with drowsiness and lower melatonin levels are associated with alertness. So basically what happens is, as it gets nighttime and less light is being stimulated into our eyes, the SEN is going to pick this up. It's going to send a signal to the pineal gland. And then the pineal gland is going to produce and secrete more melatonin. When we get some light in the morning, it will inhibit the production and secretion of melatonin. So what's going to happen is, in the morning, we get a bit of light. And right as we do, if we follow this red line, what happens is we get a massive drop in melatonin. That keeps us awake and alert. The light disappears with sunset. And our pineal gland goes, right, I need to produce more melatonin and secrete that. So then what will happen is, as you can see, if you follow that red line just above 6 p.m, you get a massive increase in the amount of melatonin. Unfortunately, as I said before, artificial light can impede this. So if you have really bright lights, if you're on your phone, if you're on your tablets, it is affecting the amount of melatonin being produced. So you're not going to go to sleep when it's dark. You're going to go to sleep when you stop having light enter your eyes. And unfortunately, it's not just your melatonin. It also regulates the body temperature and stimulating hormones such as cortisol. And hopefully you can see in this image here, whatever melatonin's doing, cortisol does the opposite. And cortisol is a stimulating hormone. So that's what's keeping us awake and alert. So if you're on your phone, you're going to continue to produce cortisol, keeping you awake and alert. you're not going to produce melatonin, so you're not going to get tired and drowsy, and your body temperature isn't going to drop. Normally, once we go to sleep, our body temperature starts to drop. So it's keeping our body going, and it means that you're probably going to eat more too, because your body is therefore going to need more energy because it's constantly needing to increase your body temperature. Now, our other cycle we were looking at is the ultradian rhythms. And as I mentioned before, these are ones that involve changes in bodily functions or activities that occur as part of a cycle shorter than 24 hours. So it can be things like performance, as you can see in this picture here. It can be heartbeat, and we get thousands of those a day. Respiration, hunger and eating behavior, alertness and activity levels, as you can see in that picture there, and sleep. So, sleep is an ultradian rhythm. We just talked about it as being a circadian rhythm. So how is it a less than 24-hour rhythm? Well, sleep isn't a single constant activity. It's actually distinct different states and stages. And we're going to look at that in more detail as we go through this topic. And we don't call it stage 5, we call it REM sleep. But there are alternating periods of sleep with and without rapid eye movement, or REM sleep, and other physiological responses that change with each stage of sleep. And our average sleep cycle only lasts for about 90 minutes. So over a course of the night, if you're asleep for 8 hours, you've actually experienced several different sleep cycles. It's why sometimes you will wake up and feel quite awake, and other times you'll wake up because your alarm was set off and you are really drowsy. All right, have a go at the activities in Compass. Thank you.